Okay, page 10 of quadratics. We're going to be doing more graphing here, but they're going to be looking at graphing from a transformations perspective. And next chapter or in a couple chapters, we are going to be looking at transformations in more detail. But right now, we're just going to take a more superficial look at it. Remember with transformations, one of the possible transformations is translations. Translations is what you see here. You're moving a standard parent function, which is this one. You're moving it to left and right, up and down, without basically changing the shape of the parent function. So that's what we're going to look at. We're going to look at translations, okay? And actually, the vertex form of the parabola of the quadratic equation is actually a translations format of the equation, okay? And basically, what H and K do, H and K are translations to the left and right and up and down of the vertex, right? Because H and K are the coordinates of the vertex. So, here it says to use completing the square to find this equation, and then graph the equation, right? In our case, what we're going to do is we're going to get to this form, vertex form, simply by finding the vertex, because I think that it is a little bit easier than completing the square. So unless we're forced to complete the square, maybe we could just find the vertex and put it into vertex form, okay? But if we do need to complete the square, we'll learn how to do that on a separate page. Okay, so the first equation we have here is x squared minus 2x plus 3. So the x-coordinate of the vertex is going to be negative b over 2a, because that's the axis of symmetry equation, but it's also the x-coordinate of the vertex, right? So it's going to be minus negative 2, so it's 2, over 2 times 1, which is a, and so it's 2 over 2 is equal to 1. So the x-coordinate is going to be 1. The y-coordinate we can find by plugging the 1 into this equation for x. So we could put y equals 1 squared minus 2 times 1 plus 3, which is equal to 3 plus 1 is 4, minus 2 is 2. So the vertex is 1, 2, right? All right, now what does that look like when we put that into the vertex form equation? Y equals x minus 1, which is the x-coordinate, squared, plus 2, which is the y-coordinate. Okay? Now that we know the vertex form, we can try to graph it. So in this case, we have the vertex at positive 1, and the in the x direction, and plus 2 in the y direction. And then we can assume that it's a standard parabola which goes up at a rate of 0, 1, 2, 4. So 0, 1, or 0, 1, 4, I'm sorry. So this is 0, this is height 1, this is height 4. Do you see how it goes up at that rate? Alright, and the vertex is here. Alright, that was the first one. Let's do C. C has B of negative 4, A of 1, and C of 0. So let's find the x-coordinate of the vertex. If x equals negative B, which is negative minus 4, so it's positive 4, divided by 2a. So x equals 2. And then the y-coordinate would be y equals 2 squared minus 4 times 2, which is going to be 4 minus 8, which is equal to negative 4. Okay, so y equals negative 4. So the vertex is, I'm using the wrong color. Vertex would be 2, negative 4, right? And it is also a standard size parabola because the a value is 1. if the a value is positive 1, we know what it's going to look like. It's going to open up, and it's going to be a standard size parabola that rises at a rate of 0.14. Here I'm going to put the vertex at 2, -4, and then I'm going to put the next points at 1, and put the next points at 4. Okay. Something like that. The one after 4, let's see, 3 squared is 9, so that would be up here. That would be the next point. Okay? Going on to E. By the way, did you notice here that the y-intercept is at 0, 0? That's because C is 0, right? E, we're going to put x equals, x equals negative b, which is -5, divided by 2. Okay, -5/2. And the y value is going to be, -5/2 is -2.5, right? So here it's going to be -2.5 squared plus 5 -2.5 minus 2. And so that would be, so the y-coordinates could be -8.25. And so the form of the equation is going to be y equals x plus 2.5. It's plus because it's minus a -2.5 squared minus 8.25. So if I'm going to draw this one, I'm going to put the vertex at -2.5 and -8.25. So around there. Okay, and then we can tell that it's a standard width parabola because the a value is 1. So it's going to be kind of hard to draw this because these numbers are like not exactly. Okay, we'll do the best you can. Alright, so it looks kind of like that. Alright. Let's go down. We're going to do one of these by complete the square, just to show you how that works. So if they say to complete the square, then we're going to try to find a magic number so that we can make a perfect square out of this. Okay, I'm just going to do that over here just so that you can see what that looks like. So x squared minus 6x plus mystery number. What number could we put here in the mystery number so that it would turn into an exact square? What I mean by that is I want it to come out to be x minus something squared, and then that expanding with FOIL would turn into that. So what if I put in a number like plus 9? And then I'm going to say that, okay, if I factor this, it's going to be x minus 3 squared, and that works, right? Because -3 squared gives you 9. X squared, of course, gives you x squared, and the middle term you get by doing the outer inside part of FOIL, the OI. You can get x times -3, that's -3x. You add that to another -3x, you get -6x. Hey, it worked out. And then you're like, Mr. Tsubaki, how did you ever guess that the magic number was 9? Well, there's a formula for it. You could take the -6, you divide it by 2, then you get -3, and then you square it. And then that gives you positive 9. And so that is how you get the magic number. You divide it by 2 and you square it. And look at this, -3, which is the intermediate number in the process of dividing by 2 and squaring it, that turns out to be this number here. Okay, so when you do that, you're already figuring out what this squared looks like. Okay, and I'm going to erase all this just for a second because we need to move on. Okay, so we know that this is going to reduce to x minus 3 quantity squared if we can just put a 9 in here. So what we're going to do is we're going to add a 9. And then we're going to immediately subtract it. Because that way, we're just adding 0. Because if you add 9 and subtract 9, you're adding 0, which is perfectly fine. You can always add 0 to something. Nobody cares, right? Okay. Then we're going to group them in this form. So the first grouping we know reduces to x minus 3 squared, because we figured it all out here. And then the second grouping, negative minus 9 plus 5, turns into minus 4. And look at that. We just turned our standard form equation into a vertex form equation. And so from here we can see that the vertex is going to be at x equals positive 3 and y equals negative 4. And it's of course a standard width parabola because the a value here is 1 again. Okay, so we're going to put the vertex at 3 and negative 4. And then it's a standard width parabola, so we can go up at a rate of 0, 1, 4, 0, 1, 4 to the left, 0, 1, 4 to the right, and basically it looks like that. The next step would be 9, so it would be up here, here, and here. Okay, and so that's when we did by completing the square. And now we'll go back to just doing it the regular way with negative b over 2a here. So here we have a is 1, b is negative 5, and c is 1. The x-coordinate is going to be negative 5 over 2. So it's 5/2, 2.5. And then we're going to have the y value, which is 2.5 squared minus 5 times 2.5 plus 1. So that's going to be about negative 5.25. And now if we want to write that as in vertex form, we're going to put x minus 2.5 because the vertex is positive 2.5 and then negative 5.25. And then we're going to put squared, and then we're going to put minus 5.25. So the x-coordinate is going to be 2.5, positive 2.5, and the y-coordinate is going to be negative 5.25. So positive 2.5 and negative 5.25. So it's about there. Oops. And it's going to be a standard parabola. So it goes up 1 unit, and then it goes up about 4 units. So it looks about like that. All right. Okay, and that's it for this page.